Hello. Welcome to my channel. In this video we are going to see the possible relative positions between two circles. The first case we analyze is the one with two circles lying outside each other. In this case the circles never touch. And if we call C1 and C2 the two centers of the circles, and R1 and R2 the two radii of the circles, we can state that the distance between the two centers is greater than the sum of the two radii. This is clear if we rotate the two radii so that they lie on the same straight line to which the segment C1-C2 belongs. If we call A the point of intersection between the segment C1-C2 and the blue circle, and B the point of intersection between the same segment and the yellow circle, we can state that the length of AB is equal to the difference between the length of C1-C2 and the sum of the radii. This is the shortest distance between 2 points of the two circles. The second case we want to see briefly is the case of concentric circles. Concentric means that they have the same center. If the two circles have different radii, then one is contained in the other. If they have the same radius, the two circles coincide. In figure we have two circles of center C1 and radius R1 and R2. The shortest distance between 2 points of two concentric circles is given by the difference of the radii. This is the case of the points F and G in figure. Two circles may also intersect at two different points. Like in figure. If we want to find the coordinates of the points of intersection, we have to solve the system with the equation of the two circles. The blue circle in figure has equation x minus 1 squared plus y minus 1/2 squared equals 8. While the yellow circle has equation x plus 1 squared plus y squared equals 4. We solve the binomial squares. Then we can subtract the first equation from the second. In this way the terms x squared and y squared cancel each other out, and we get a linear equation in x and y. We have 4 times x plus y plus 15/4 equals 0. We get the value of y, and we substitute it in the equation of the second circle. We obtain a second-degree equation in x that we solve by applying the quadratic formula. We get two values of x that correspond to the two abscissae of the 2 points of intersection. There x1 equals minus 0.456 and x2 equals minus 1.426. To calculate the values of the ordinates, we know that y equals minus 4 times x minus 15/4. So we insert the values x1 and x2 into the equation, and we get y1 equals minus 1.926 and y2 equals 1.954. These are the coordinates of the points of intersection of the two circles in figure. Eventually we analyze the case of two tangent circles. We start by saying that there are two possible cases. In fact, the circles may be tangent externally or internally. Two circles are tangent internally when one of them is contained in the other and touches it at a single point. If we call R2 the radius of the small circle and R1 the radius of the big circle, the distance between the centers of the two circles, green in figure, is equal to R1 minus R2. In fact, the point of tangency belongs to both circles. So if we consider the two radii from the centers to this point, it's evident that this equation holds. Two circles are tangent externally if they lie outside each other touching at a single point. This is the case of the blue circle and the red circle in figure. If we draw the radius of the blue circle from the center to the point of tangency, and we do the same thing for the red circle, it's clear that the distance between the two centers C1 and C3 is equal to the sum of the radii. The yellow circle of the previous example is tangent internally to the blue circle, at the same point at which the red circle is tangent externally. So even the red circle and the yellow circle are two tangent circle. More precisely externally tangent. Therefore the distance between C2 and C3 is equal to the sum of R2 and R3. Well, this video is over. If you like my videos, you can subscribe to the channel. See you soon with another video. Bye.